Hi, ladies and Russ. Let's talk about probability, you guys. So we've all had a little time off for spring or fall break. So just to bring this stuff back to your memory. An activity involving chance, such as rolling a cube, is called an experiment. Each repetition or observation of an experiment is a trial, and each result is an outcome. A set of one or more outcomes is an event. For example, rolling a 5, which is one outcome, can be an event, or rolling an even number, that means there's more than one outcome, can be an event, right? So the probability of an event is always written the capital P and then whatever you're looking for in parentheses. For example, if I was looking for an even number, it would be capital P parentheses even. Is the measure of how likely an event is to happen. Probability is measured between 0 and 1, as shown on the number line. You can write probability as a fraction, a decimal, or percent. So if the probability of something happening is 100%, that means it's definitely going to happen. If the probability of something happening is 0%, that means it's impossible. And everything in between tells you how likely or unlikely an event is to happen or not to happen. So determine whether each event is impossible, unlikely, as likely as not, which is 50%, likely, or certain. So if you have a number cube and you're going to roll an odd number on a number cube, well, half the numbers on a standard die are odd, right? So that's a 50% chance of happening. So that would be as likely as not. There are 6 possible outcomes on a number cube. You can get a 1, 3, or 5, which are odd, or 2, 4, and 6, which are not odd. So half of the outcomes are odd. Rolling an odd number is as likely as not. That's the probability is 50%. So determine whether each event, so on and so forth. It says rolling a number less than 2 on a number cube. Well, how many numbers on a number cube is less than 2? Well, there's 6 possible outcomes. The only number that's less than 2 on a number cube is a 1. So the probability is 1/6. So it's not impossible, but 1/6 is unlikely. It's a small fraction, right? So if you have a bag that holds 4 red marbles, 3 green marbles, 3 yellow marbles, and 2 blue marbles, you pull one without looking. The probability of pulling a green marble is 1 out of 4, because we would have 12 marbles in the bag. So 3 out of 12 would simplify to 1/4. What is the probability of pulling out a marble that is not green? Well, if there's a 1 out of 4 chance of getting a green one, then you would subtract that from 1 whole. And that means the probability of pulling out a marble that is not green is 3/4, which is going to be likely. All right, so Tim never listens to his MP3 player during classes. So if Tim is in math class, how likely is it that he's listening to his MP3 player? Well, if he never listens to it during class, if he's in class, it's impossible that he's listening to his MP3 player. So Lawrence finds the experimental probability of his reaching first base is 40%. Out of 350 at-bats, how many times can he expect to reach first base? So basically, you're just finding what is 40% of 350. So I would multiply 350 times 40% as a decimal, which is 0.4. So I would multiply 14. I have one number behind the decimal. So if he was at bat 350 times, you would expect him to reach first base 140 times. So basically, that's what they're doing as well. They're multiplying by the fraction 4/10 and got 140. Yeah. All right, Malia finds the experimental probability of her scoring a goal is 20% out of 225 attempts. How many times can she expect to score a goal? So once again, we just need to find 20%, which is 0.2 of 225, which means we're multiplying. So 5 times 2 is 10, 2 times 2 is 4, plus 1 is 5. And there's one number behind the decimal, so the answer is 45. She can expect to score a goal 45 times out of 225 attempts. All right, the experimental probability of Mara shooting a goal in field hockey is 12% out of 300 shots. How many can Mara predict will be goals? All right, you guys do these two problems and then check your answers, please. So on number 1, we're multiplying 300 times 0.12, 0, 0, 6, 0, 0, 3, 0, 0, 6, 3. 2 numbers behind the decimal, so this one's 36. Did you guys get that? And then if he flips 2 quarters 25 times, how many times can he expect to flip 2 heads? Well, 2 quarters 25 times. So basically it's 50%, because every time he gets, the probability of getting heads on a quarter is 1/2. How many times can he expect to flip 2 heads? So he's going to flip. So the first time, so the probability of getting heads out of 25 is 1/2, right? So if he gets heads the first time, and then if he gets 1/2 heads the second time, there's a 1/2 probability. So to get 2 heads in a row is 1/4. So we haven't really talked about compound events yet. So I don't really like this question, but basically you take the probability of the first event, you multiply it by the probability of the second event, and that's what the probability of getting 2 things in a row. So 25%, 1/4 is the same as 25%. So I'm going to multiply 25 by 0.25. So 5 times 5 is 25, 10, 11, 12, 10, 5, 5, 2, 6. With 2 numbers behind the decimal. So we expect that to happen about 6 times to get 2 heads, doing it 25 times. That was confusing, you guys. I'm sorry. I didn't look at these before I did them with you. All right, I've lost my mouse. Here it is. All right, so the first one was 32. Did I multiply wrong? 0, 0, 6. 12 out of 300. I think that one must be wrong. Sorry, I should have done these before I did them with you guys. Times 0.12. No, I got 36. I think that answer's wrong. What do you girls think? And Russ, sorry. Russ, we're used to having only girls. I apologize. And then the second one is 6 times. So that one is a compound event. So I hope you understood that. Really, Thursday's lesson is on compound events. So we'll practice that more on Thursday. All right, let's look at this one. It says, what's the probability of rolling a 5 or 6 on a number cube? Well, how many 5s are on a number cube? There's 1. How many 6s are on a number cube? There's 2. There's 1. So there's 2 chances out of 6 of rolling a 5 or a 6. So if I simplify 2 over 6, I get 1 out of 3. So, or that equals 0.33 or 33 1/3%. All right. So that means if I conducted 180 trials, predict the number of times the outcomes would be 5 or 6. Well, I want to multiply 180 times 1/3. 180 times 1/3. Of course, I don't want to multiply by a non-terminating decimal, right? So I'm just going to do it this way. So if I multiply straight across, I get 180 180 over 3, which is 60. 60 is the right answer. All right, you guys try these and then check your answers, please. What is the theoretical probability of rolling a 3 on a number line? Well, there's only one 3, right? So it would be 1/6. If you roll the number cube 24 times, how many times should it land on a 3? Well, there's 1/6 chance of getting a 3 out of 24 times would equal 24/6, which is 4 times. So we're multiplying the probability by how many times we're doing the experiment. After rolling a 6-sided number cube 24 times, Sally rolled a 3 6 times. Do the theoretical and experimental probabilities match? Well, they don't match, right? No, they do not match because theoretically, we would get a 3 4 times. So 4 out of 24 does not equal 3. Oh, 6. It says roll a 3 6 times. So their experiments was 6 out of 24 times. So these two fractions do not equal each other. No, they don't. But how much do they differ? Differ means to subtract in math. So let's take the smaller number away from the bigger number. By how much do they differ? Well, they differ by 2 24ths, which is equal to 1/12, right? The difference of 1/12. And then what could Sally do to make them match more closely? Well, what could you ever do to make the theoretical and experimental probabilities match more closely? The answer will always be conduct more experiments. Conduct more experiments. Do it more than 24 times. All right, what about this one? The probability that an event will occur is 1/8. Which of these best describes the likelihood of an event occurring? Well, as likely as not is always 1/2. So this number we need to think is either more than 1/2 or less than 1/2. Well, half of 8 is 4/8. So this is unlikely, which is not a choice. I don't like any of these questions. It's not certain. It's not as likely as not. It's not impossible, but the answer would be unlikely. Let's change this response to unlikely. It's a bad question, everybody. Yep, that's not a good question. All right, maybe we'll do better the next time. The probability that an event will occur is 0.9. Wow, that's really close to 1 or 100%, right? 0.9 is really close to 1. So which of these best describes the likelihood of the event occurring? It's not certain, but it's definitely likely because that's really close to the number 1 whole. Or, yeah. All right. The probability that an event will occur is 50%. Which of these best describes the likelihood of the event occurring? Well, 50% is always going to be as likely as not. 50%. Marcus flipped a coin. Oh, my screen is in the way. Marcus flipped a coin 800 times and it landed heads up 560 times. What is the relative frequency of the coin landed heads up based on the results of this experiment? So based on this experiment, it landed heads up 560 out of 800 times. So I'm just going to use my little handy dandy calculator. I'm going to divide 560 by 800. And I got 0.7. So 0.7, what percent is that? Move your decimal to the right 2 places. So 70% of the time it landed heads up. Let me erase what I've written. A 6-sided number cube labeled 1 through 6 is rolled 600 times. An odd number is rolled 272 times. Compare the experimental probability of rolling an odd number with the relative frequency, which basically means the theoretical probability of rolling an odd number, and select one of the statements below. All right, well, first, before we see the statements, let's compare them. So there's half the numbers on a number cube are odd. So theoretically, we would land and get an odd number 300 out of 600 times, 300 out of 600. Well, in this experiment, they got it 272 out of 600 times. When it says compare, let's go ahead and say that the experimental probability is less than the theoretical probability, right? 300 minus 272 is 28. So the difference in the probabilities is 28 out of 600. So let's see what our choices are here. It says the experimental probability. So basically we're comparing experimental probability to, excuse me, this is theoretical. The theoretical probability compared to the, oh my gosh, ladies, Russ, I don't know what I'm saying. The theoretical probability, which is this, is greater than the experimental probability. Okay, so let's see which one says that. The experimental probability, which is 272, is smaller than the theoretical. That's not true. The experimental probability, wait, let me go back to letter A. I need to get my thoughts together. The experimental probability, which is 272, experimental probability is smaller than the theoretical. Oh, actually, that is true, right? Letter A is true. Letter B is not true. The experimental probability is not larger, it's less than. The experimental probability are the same. Nope, that's not true. And there's not enough information. Nope, there is enough information. So A is the right answer. Only took me 3 times to get that one right. All right, let's look at the next one. A bag contains 50 marbles, 10 of which are blue, 8 are red, 20 are green, and 12 are purple. Marcy takes a marble out of the bag, records the color, and returns it to the bag. How many red marbles should she expect after 500 trials? Well, there's 50 marbles, and 8 are red. 8 out of 50. And we're going to do 500 trials. So what times 50 is 500 times 10. So we can do the same thing to 8, right? So we would say 80. So 80 times she should pull out a red marble based on our proportion. All right, let's see what the next one says. If the theoretical probability of an event is 75%, does that mean every time someone conducts an experiment 100 times, they will get the desired result exactly 75 times? You guys know that's not true. No, it doesn't mean that. Just because you do an experiment and you get an event 75% of the time doesn't mean the next person that does that experiment is going to get the same result as you. No, that's not what it means. Number whatever, the last one maybe. Is it the last one? I think it is. A bag contains 20 marbles of the same size that are blue, green, and red. The probability of picking a blue marble is 20%. The probability of picking a green marble is 50%. Determine the probability of picking a red marble from the bag and then classify the probability of picking a red marble as likely or not likely to occur. Well, if all the bags, excuse me, if all the marbles are blue, green, and red, that means that 100% of the marbles are those colors, right? So if we start with 100% of the marbles and we take out half of them, which are blue, excuse me, green, and then we take out 20% of them, that means 30% of the marbles remain. 30% must be red. So what is 30% of 20? Well, that's going to be 6 red marbles. Did that make sense? If you add up these two percents, you get 70%, which means the rest of them, the rest of the 100% have to be red, which means 30% of them. Well, 30% of 20 is 6 red marbles. So 6 out of 20. Is this going to be as likely or not likely to occur? Well, as likely or not likely is 50%, and 6/20 is not 50%, because it would be 10/20 would be as likely as not. So this is, I guess you would have to classify it as unlikely. This is unlikely because it's less than 50%. All right. Yep. All right, girls, and Russ. Sorry, Russ, I always leave you out. I hope that helps you guys. You guys are going to take your mid-module quiz today, and then tomorrow we'll meet together and talk about compound events or independent events. Have a great day. If you need me, let me know. I'll talk to you guys later.